Hey guys, so we're here to talk about our statistics project. Our project was our research question was: is points per game a good predictor of salary for NBA basketball players? Ale, why don't you tell us about the goal of the project?
All right, so what we did was we wanted to be able to see if an average points per game during the 15-16 basketball season would be a good predictor, like their average points per game for that season would be a good predictor for their salary the following year 16-17 season. So what we did is we picked randomly 15 teams, NBA teams, and then within those teams we picked two players from each team, so we have a total of 30 data points. Our observational units were the explanatory variable was average points per game in the 15-16 season, and then the response variable is their 16-17 salary.
So the population that I should be able to generalize is NBA players because that is the population that we are randomly selecting.
This is our data as shown from 2015-16 season. We randomly selected two players from 15 NBA teams, and those players are Leandro Barbosa, Jared Dudley, both from the Phoenix Suns, Justin Holiday, Joakim Noah from the New York Knicks, Alfred Payton, Bismack Biyombo from the Orlando Magic, PJ Tucker and DeMar Carroll from the Toronto Raptors, Seth Curry and Nerlens Noel from the Dallas Mavericks, Wayne Ellington and Luke Babbitt from the Miami Heat, Aaron Brooks and Lavoy Allen from the Indiana Pacers, Wilson Chandler and Darrell Arthur from the Denver Nuggets, Kyle Singler and Doug McDermott from Oklahoma City Thunder, Boris Diaw and George Hill from the Utah Jazz, Steph Curry and Draymond Green from the Warriors, Marcus Smart and Isaiah Thomas from the Boston Celtics, Eric Gordon and Trevor Ariza from the Houston Rockets, Brooke Lopez and KJ McDaniels from the Brooklyn Nets, Marco Bellinelli and Michael Kidd-Gilchrist from the Charlotte Hornets.
This is the scatter plot of our graph, of our data. You have the points, the explanatory variable on the x-axis, and the money, their salary paid in the 16-17 season on the y, which is the response variable. There's no apparent pattern in this, and there seems to be a moderate linear positive relationship between both variables.
Right here is the equation for the least squares regression line, and in context, this means that the predicted salary equals 3.01 plus 0.4569 times average points per game. So right here is the correlation coefficient, so R equals 0.495, and in context, that means that it's the moderate linear relationship between the average amount of points someone scores and the amount of money that they will receive for the next season.
Alright, R squared is the coefficient of determination, and that is 0.245, and that in context means that 24.5% of the variability in the salary may be explained by the linear relationship with average points per game the previous season.
So this is a copy of our null distribution, and the applet created a null distribution by shuffling the salaries paid and pairing them randomly with the average points per game during one season. This demonstrates what may have happened if there was no relationship/correlation between the amount of points a player averaged in one season and the amount of money they are paid the next season. Our strength of evidence, with a p-value of 0.0020, there is a strong evidence in favor of our alternative hypothesis. To obtain this, we place our sample slope of 0.4369 on the simulated null distribution and to see how often a slope of that or greater was obtained just by random chance. We will count the number of times out of the total of values that our slope or greater was obtained. This will be our p-value. For our conclusion, there was strong evidence in favor of our alternative hypothesis. Due to the p-value that was less than our alpha value of 0.05, we may conclude that there is strong evidence supporting a positive linear relationship between the average amount of points an NBA player scores during one season and their salary the next. Some errors that could have occurred may include a disproportionate number of all-stars in our sample. Big names tend to be paid more because they are more likely to sell seats. Moreover, we did not assess other stats like assists, free throw percentage, etc., and those may all contribute to a lower or higher salary. So to construct a 95% confidence interval for the population slope between our explanatory and response variables, with the values of 0.1402 and 0.7336, we can be 95% confident that the slope for predicting salary based off average points per game is between those values. Error may have been arisen due to the sources we used to collect our data. We collected our sample from the same two sources times throughout the study. However, different salary websites may vary. There are many variables that go with NBA players' salaries because at the end of the day, NBA teams are trying to make money. Big name players will most likely be paid more. Moreover, it would be interesting to look at other stats in order to evaluate and conclude which stat a team values, quote unquote values, more in reward with the highest salary. Thank you.